Hello, y'all. This is 5.7 notes. Go ahead and throw your name on your sheet of paper. And then remember, we have already done 5.7, or we've already done 5.8 and 5.9. 5.7 was supposed to happen on one of the snow days, and we're hopping back to it. So 5.7 is its special own method of factoring. It's the easiest, funnest special rule out there. So it is called difference of squares. Difference meaning subtraction, and then squares meaning perfect squares. So the first thing that we're going to look at is why we need this rule, why this rule is relevant to us. And we're going to do that by multiplying out this binomial, 5x plus 4 times 5x minus 4. So I'm going to throw this on our 2x2 box that we learned about in 5.4. And then let's go ahead and multiply this out. So 5x to the first power, 5x to the first power. And the top left box, 5 times 5 is 25. We add our exponents. 1 plus 1 is 2. In the top right box, 5 times negative 4 is negative 20. We bring over that x to the first. Bottom left-hand box, 5 times 4 is 20. Bring down that x to the first. And in the bottom right-hand box, 4 times negative 4 is negative 16. So once we get those things multiplied together, we would combine like terms for our final answer. We can combine this 20x to the first and the negative 20x to the first. So we're going to write things in standard form. 25x squared will go first. These two guys, when we combine them together, they will cancel each other out. So 20 minus 20 completely cancels out. We have no x to the first left. And then we have minus 16. So we've got 25x squared minus 16. Couple things that you can notice. 25 is a perfect square. It is 5 times 5. Negative 16, well, not negative 16, but 16 is a perfect square. It is 4 times 4. So this is a difference, subtraction, of two perfect squares. And those squares are whatever 5 times 5 is, which is 25, x times x, which is x squared, and then this 4 times 4 is where we get the 16 from. So that is the special rule that we're going to use today. It is written down right here, and is that a squared minus b squared. So anything squared minus anything else squared can be factored out to be a plus b times a minus b. So that is difference of squares. Before we move on, let's review our perfect squares just so we can make sure we're on the same page about those. I think in your assignment you need to go up to 225. So let's go up to 225. So 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. And 5 squared is 25. Give you a second for those. I think most of us have most of those memorized. 6 squared is 36. 7 squared is 49. Sorry about the grandfather clock in the background. 8 squared is 64. 9 squared is 81. And 10 squared is 100. And then let's do 5 more, and I'm going to remind you how to look at these in your calculator too. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. And 15 squared is 225. I believe that's as high as I went on the assignment, but if I went higher, or if we forget any of those, don't have them memorized, just want to double check ourselves, we can always do that using our calculator. So let me split this view, pull up a calculator. So in a calculator, which your guys' should look just like this without an add at the top, we can always either take a number and square it. So if I take a number, type in, gotta clear it first, type in 5. The squared button is over here on the left side. It's where it says x squared. So 5 squared is 25. And then alternatively, if we want to find the square root of something, so undo squaring something, we have to hit the second button and then hit that x squared button again. The square root button is right above the x squared button, and we would type in 25. So square root of 25 is also 5. So again, let's say we are working with way higher numbers. Say we've got 17. 17 squared is 289, and the square root of 289 is 17. Awesome. Okay, back to here, let's look at our examples. So we've got x squared minus 36 as our first example. The first thing that we're going to look at is x squared is what squared? And x squared is just x times x. So I'm going to write down over here that a equals x. And then b is what squared is 36. So 6 squared, or so 36 is just 6 squared. So if a is x and b is 6, using our rule up here, our factored form is going to be a plus b times a minus b. So that would be x plus 6 times x minus 6. And that's it. Super short and sweet. Okay. Next one we've got 4x squared minus 81. So 4x squared, 4 is 2 times 2, and x squared is x times x. So our a here is going to be 2x, because 2x times 2x would be 4x squared. And then our b here is going to be 9, because the square root of 81 is 9. 9 times 9 is 81. So then our factored form would just be 2x plus 9 times 2x minus 9. Okay, we've got 2 more examples, because there's no back on this note sheet. So 25x squared minus 49. 25x squared is 5 times 5, and x squared is x times x, so a will equal 5x. And then b, 49, is 7 squared, so b will equal 7. So multiplying this out, factoring this, our factored form would be 5x plus 7 times 5x minus 7. Okay, and then our very last problem, we've got 9x squared minus 81. Our a value is the square root of 9x squared. So square root of 9 is 3. Square root of x squared is x, so 3x, because 3x times 3x, 3 times 3 would be 9, x times x would be x squared. And then the square root of 1 is just 1. So 1 times 1 is 1. So our factored form would be 3x plus 1 times 3x minus 1. So you guys will start seeing that this is super, oh, I messed up there. 3x minus 1. So it's got to be 1 plus and 1 minus, because that plus and minus is what makes our middle terms cancel out. If we remember back up here, that's what made those middle terms cancel out. So things to remember, has to be perfect squares, and it has to be a difference. It has to be a subtraction. Once we figure out that it's perfect squares and it's a difference, then it's the square root of your first term, the square root of your second term, and it's 1 plus version and 1 minus version. That is it. You guys can get to work on your assignments now.